right, so in chapter 4, we're dealing with relationship between two variables. And so right now we're dealing with quantitative relationships between two variables. We're looking at a correlation coefficient. So the book talks about this R value as being something that goes in between -1 and 1, where -1 is perfect downward relationship, a linear relationship, and then a +1 is a positive relationship. Maybe my hands are backwards for that one with Jarl's viewpoint. So, but going up is a positive, going down is a negative. And so we're going to have to learn how to calculate this R value and determine whether it's a good enough linear fit. Again, the closer to 0, the less linear relationship it has. But we are not the judge of does it fit well enough to be linear. So we'll look at some critical tables too in this section. So looking at this example in number 2, match the linear correlation coefficient to the scatter diagram. So they've created some scatter plots. We can do that in StatCrunch pretty easily. And looking at these, you know, if we're just kind of getting a feel, which one is, they're all going down, so we have the negative. Which one looks about perfect, which one is, you know, looks pretty good, and which one doesn't look as good. So looking at this one and this one, like this one looks pretty linear, and so that would be my -1. It's going down, and all the data points look to be lined up. This one is close. You know, there's some wiggle room in there, but very rarely in collecting data you're going to get this nice, exactly linear. So this might be my -0.992, and this one's a little fuzzier. We see it's going down, and it's a -0.049. So it is going down, but again, that one's pretty close to 0. But right now, I'm not going to say whether or not it's a good enough fit. So another one I wanted to look at was number 6. And in number 6, they're having you look at the table. So they find correlation between a couple values. In this case, it's the background questionnaire and mean score. So they're comparing these two things, and they get a .721, which is kind of close to 1, but again, how close to 1 is good enough? So we know that we have 41 nations participated in the exam. So that is going to be our sample size that we're looking at. And when we do that, we have these critical values that are going to be provided for us in tables. There's a table in the back of the book that's going to have critical values for correlation coefficients. So we're looking at one that has, you know, 41. And if it's .361 or higher, the absolute value, so ours was .721. If it was a -.721, we would look at the absolute value of that. Because again, -1 is perfect as well, just in a different direction. So since our 41, right, is greater than .361, our table only goes up to 30, we can say that it does have a linear relationship. And that's something that we're going to use this table to help us decide whether or not there is a linear relationship. So does it suggest a linear relationship between these two things? The answer would be yes, since it's greater than that critical value of 30. Again, we have 41. But if it's good enough for 30, 41, we have more data and we have a higher R value. So I feel good clicking that one. And then wait for our high 5 that my stat lab gives us. I think one day I want to talk to my stat lab people and tell them to put high 5. That would be fun. And then looking at this, what does this mean? And so that's where you have to interpret your results that you found. Sometimes that's the toughest thing, interpreting, because there's a lot of different interpretations that people have. The next one I want to look at is number 7, and this is actually calculating an R value. We can do a scatter plot, and there's several different ways to do it, but I'm going to show you a way that I would suggest to you. So if we take our data, so height and head circumference, we open it up in StatCrunch. And I'm going to make a scatter plot that'll give us an idea of what the data looks like. And then we'll calculate our R value. So here I could do a quick graph if I wanted to. I could do a scatter plot. And I would say my X variable is heights, my Y variable is head circumference, and let's just go ahead and compute that. And so we see maybe it's positive, it's going, looks like it's going up. Now what is the R value? Not quite sure, but we see this. So that gives us a scatter plot. But there's a whole bunch of different ways to do a scatter plot. There's regression, simple linear. This is the one that I'm going to suggest. There's also different things that we can do in summary stats, like a correlation. So that's what we're looking for, a correlation coefficient. But I'd like us to use regression because it's going to be something that we can use for all of Chapter 4. So we're going to do a simple linear, same thing, height, and then circumference. And from here, we're not going to do anything in here. Some more things we can do later with this. But what we're going to get a lot of information. Again, we're going to use some of it later. It gives me a correlation coefficient, right? It gives me this R value, 0.803. So that's how well there is a linear relationship between these two items of height and head circumference. It also will give me a picture and a line that best fits the graph if we are going to say it's linear. And so we do get the scatter plot. We get kind of this fitted line to it, which we'll talk about in another section. And we get our correlation coefficient. So that's very handy. It does a lot of things in one place. And so to get there again, stat, regression, and then simple linear. And that'll help us solve these other problems in section 1.